All right, let's just dive right in. For the last couple of years, we've all been blown away by AI that can chat, write code, and make incredible art. But you know what? That was just the warm-up. We're on the brink of the next huge leap in AI, moving from AI that just responds to us to AI that actually acts.
So, to really get where we're going with this whole idea of digital swarms, we first need to understand the basic building block, the thing that makes it all possible, the AI agent.
And this slide, this really cuts to the core of it. We all get generative AI by now, right? You give it a prompt, it gives you back some text or an image. Super powerful, for sure, but it's reactive. Agentic AI, though, it's a whole different ballgame. You don't give it a prompt, you give it a goal, and then it goes off and figures out all the steps to get there by itself.
So what does agentic really mean? Well, think of it like a continuous loop. First, the AI perceives its digital environment, maybe through APIs or by reading websites. Then, it actually reasons and plans out a strategy to hit its target. After that, it takes action. It might execute some code or send an email. And here's the kicker. It reflects on the result and self-corrects if it messes up. It's that full cognitive loop that makes it truly autonomous. And listen, this isn't just some cool research project. The economic scale here is just wow. Projections are pointing to a $93 billion market in less than a decade. Some are even calling it the fastest enterprise tech adoption curve in history.
So, that huge economic shift, it's going to cause a massive societal one, too. Goldman Sachs estimates that a staggering 93% of all white-collar, knowledge worker jobs are going to be significantly impacted by this tech by 2030. This isn't just another app update, you guys. It's a fundamental restructuring of how we work.
This single agent, this is the revolutionary core. It's a system that can take a pretty complex goal. Something like, hey, research all my competitors and write up a summary, and just do it. Start to finish, no hand-holding.
This is where it gets really wild. If one agent is like a super smart employee, what happens when you network thousands of them? Well, they become something else entirely, something with an intelligence that's bigger than the sum of its parts. They become a swarm.
But here's the catch. Getting thousands of these autonomous agents to actually work together, that creates a huge problem. It's a challenge computer scientists have been banging their heads against for decades. It's called the consensus problem. How do they agree on anything when there's no boss?
I mean, really think about that. If they're all zipping around doing their own thing, how do they coordinate? How do they know they can trust each other? How do they land on one correct answer instead of just flying off in a million different directions?
To solve this, these systems have to be ready for two kinds of failure. The first one, crash faults, is pretty simple. An agent just freezes or shuts down. You can plan around that. The much harder problem is what's called a Byzantine fault. This is where an agent doesn't just crash, it actively lies. It sends bad data. It's basically a digital traitor in the ranks, and building a system that can still function with traitors inside, that's the holy grail. And this is where large language models completely change the game. The solution to getting agents to agree is evolving from these rigid mathematical formulas to something that looks a whole lot more, well, human. It looks like conversation.
This is such a brilliant way to think about it. Instead of complex code, the agents use strategies we can all understand. You can have a team of agents playing different roles. One's the planner, another is the executor, and a third one is the critic checking their work. Or you can just have them debate each other to poke holes in a plan, which, by the way, has been proven to cut down on AI making stuff up. And sometimes it's as simple as taking a vote.
Now, without getting totally lost in the weeds here, this chart just shows how things have evolved. Old-school methods like Raft are fine for simple crashes, but if you want to handle LLMs that might lie or hallucinate in a big, untrusted network, you need newer ideas like debate or something called weighted Byzantine fault tolerance, which basically gives more voting power to agents that have a better reputation.
Okay, so let's shift gears and see how this is actually being used out there. Because it turns out, the best design for these AI swarms has been running beta tests for millions of years in nature.
So much of this is directly inspired by what animals do. Take stigmergy. It's a fancy word, but the idea is simple. Indirect communication. An ant leaves a pheromone trail to tell other ants, hey, good food this way. An AI agent does the exact same thing by leaving a digital pheromone, like a note in a shared database, for other agents to find. They never have to talk directly. And what you get is emergent behavior, like those incredible starling murmurations, where you see these complex, beautiful patterns arise from just a few simple rules.
And this isn't theoretical.
It is already being rolled out with mind-blowing results. In finance, trading swarms are boosting returns. In healthcare, multi-agent teams are cutting down diagnosis times by 40%. In cybersecurity, swarms are finding threats in 4 minutes, compared to the industry average of over 3 hours. And in logistics, companies like Amazon are reporting 75% efficiency gains with their warehouse drone swarms.
Now we have to touch on the most ethically complicated application, which the source material does address: military swarms. The absolute critical difference here is the level of human control. In a human-in-the-loop setup, a person always makes the final lethal decision. But in a fully autonomous system, the machine decides. And that right there introduces some pretty terrifying risks, like flash war scenarios, where AI-on-AI conflicts could escalate in minutes, way faster than any human could ever hope to intervene.
So, with all this moving so incredibly fast, where is it all going? What does the future actually look like?
This timeline really puts it all into perspective. The basic idea started back in the 90s, inspired by bugs and birds. The 2010s saw some big breakthroughs. But right here, 2022 to 2024, that's us. We are right at the beginning of this explosion, all powered by LLMs. And the path forward? Projections point to entire autonomous companies by 2030, and maybe even self-evolving intelligence by 2040.
Let's just break that down for a second. By 2030, we could have autonomous enterprises, actual companies run mostly by AI agents. A few years later, by 2035, we might see an agent economy, where AIs hire other AIs for specialized tasks, creating these super-fast markets. And by 2040, the internet itself could just become this distributed layer of intelligence that we guide with our goals.
And that really brings us to the core question raised in all the research. This isn't just about writing code anymore. The people building these systems today are designing the minds that might run the most important systems in the world tomorrow. That is an absolutely immense responsibility.
And that kind of leaves us with this final, really big thought to chew on. Throughout all of human history, technology has been a tool. It's been passive. It just waits for us to pick it up and use it. This is the first technology that's more like a worker. It's active. It pursues its own goals. And that single distinction changes absolutely everything. The biggest challenge of our time might just be figuring out how we prepare for that.